I'm Joan Miguel Romero, an MD PhD student in the lab of Dr. George Zagopoulos at the Goodman Cancer Institute at McGill University in Montreal, Quebec, Canada. My father's passing from pancreatic cancer motivated me to pursue training as a physician scientist. After completing my first 2 years of medical school, I started my PhD in January of 2021. After the completion of my PhD thesis, I will complete my final years of medical school. It's important to create large databases involving patients to best understand as many cases of this cancer as we can. This is because pancreatic cancer is one of the hardest to diagnose and treat. As such, there are several projects in the lab that are aimed to fulfill these needs. As a surgeon scientist, Dr. Zagopoulos has established the Quebec Pancreatic Cancer Study, which is the largest database of clinical information and sample biobanking for patients with pancreatic cancer in the province, with over 1,400 patients currently enrolled. Through this initiative, several projects have been started to help understand this disease on a patient-by-patient basis, including the creation of mouse avatars through patient-derived xenografts. These are created by taking a piece of the patient's tumor and inserting it into a mouse to grow, creating a model of the cancer. This allows us to study the tumor and understand mechanisms of drug resistance using these models. A key part of science and medicine is collaboration. We are one of 20 sites across Canada, the United States, Europe, and Israel involved in the Pancreatic Cancer Early Detection Consortium. By collecting clinical data and biospecimens like blood and saliva from patients across the world, this consortium aims to improve the survival of patients suffering from pancreatic cancer through researching ways to improve screening, detection, and prevention for those with hereditary risk factors. Our lab is particularly interested in a subtype of pancreatic cancer called homologous recombination deficient, or HRD, pancreas cancer. Accounting for up to 10% of cases, this specific population forms a subset of cases known as hereditary pancreas cancers. I am specifically focused on the role of HRD in pancreas cancer and the effects it can have on anti-cancer immunity. HRD pancreas cancer has defects in machinery to repair DNA damage. We now understand that certain treatments can be used to treat these cancers. Unfortunately, new treatments, like immune checkpoint inhibitors, have not impacted pancreatic cancer like they have for other cancers, such as melanoma and lung cancers. We are trying to investigate how HRD can stimulate the immune system to attack pancreatic cancer, and whether this can make patients with HRD amenable to immunotherapies. The problem with pancreatic cancer is its delayed onset of symptoms, usually leading to an advanced stage at diagnosis where the cancer has spread from the original site. In addition, pancreatic cancer is an aggressive disease that remains resistant to current treatments. By helping identify early risk factors and prevention strategies for patients through initiatives like the QPCS and PROCEED, as well as further understanding the basic biology and mechanisms that can be targeted through the work from our lab and others, the pancreatic cancer scientific community, which consists of researchers, doctors, and patient advocacy groups around the world, hopes to improve ways of detection and treatment for patients suffering from this disease.